In this video, we're going to be going over the simulate method of the FrogSimulation class. Basically, this is simulating a frog attempting to hop in a straight line where it starts at 0 and then it tries to get some sort of goal distance as defined by the field goal distance within a maximum number of hops, which is also defined by a field. We return true if it did reach that goal within the maximum number of hops, otherwise false. There's this method that we can use called hopDistance, which when we call it, it returns an integer representing the distance, positive or negative, that's moved when the frog hops. So positive means that it's moving towards the goal, negative means it's moving away. It might return something different each time. Let's go ahead and dive into the pseudocode so we sort of know what we kind of want to achieve. We know that throughout this entire method, we are going to be keeping track of the frog's current distance, where this is either moved forward or moved backwards when we call hopDistance, and we add that to our current distance. So we're going to want to initialize a variable to represent the frog's current position. Okay, and then after that, we're going to want to loop max hops number of times, and within that loop we're going to want to keep updating the frog's current position. So update the frog's current position based on hop distance, so each time we're either moving forward or moving backward. Then also within this loop, we know that we can return if certain conditions are satisfied. So if the frog has reached the goal, return true. So this is the case where we're still within our loop, we're still within the max number of hops, and the frog's distance is greater than or equal to goal distance. However, if the frog has reached a negative position, we're going to be returning false in this situation because the frog is now in a position that's negative, and that's not good. Outside of the loop, we know that the frog has already hopped max hops number of times, and if it hasn't reached the goal within that for loop and we haven't returned true, we know that we haven't reached the distance. So in this case, if the frog hasn't reached the goal within max hops number of hops, return false. So at this point, we've already called hopDistance the maximum number of times we're allowed to, and if the frog has not reached the goal, which we would have known if we had returned true within the for loop, or if the frog hadn't reached a negative position, which we also would have known within that for loop, then we're just going to be returning false because the frog didn't make it to the goal distance. So let's go ahead and convert this pseudocode into actual code. So initializing a variable to represent the frog's current position. The goal distance field is an int, the hopDistance returns an int, so we can assume that the frog's current position can also be an int. So int, say, current position, and we're going to set this at 0. The problem statement says that the frog's starting position is 0, so the current position being 0 makes sense as well. Next, we're going to be looping max hops number of times. So for int I equals 0, max hops is our upper bound. Max hops I plus plus. Max hops is our, so this is our for loop. Then within that for loop, we want to be updating the frog's current position and then checking it based on the two conditions that we can check within the maximum number of hops. So updating the frog's current position based on hopDistance. So we can say current position plus equals, we can call our hopDistance method. This is going to return an int, and what we're doing is we're just adding it onto our current position. So say, for example, hopDistance was 5, so we go from 0 to 5, and then let's say we call it again. Let's say it returned a negative number, maybe like -1, then it would be to 4. So that is how that would work. So now we have the current position after the frog has hopped, let's say maybe 1 time. We want to check if the frog has actually reached the goal. So it's very possible that maybe the goal distance was 5 and the frog went 5 distance. So we need to check if it reached or passed the goal. So either one of those means that the frog has reached the goal. So that would be if current position is greater than or equal to goal distance, where goal distance is that field that we have in our class. So if that happens, return true. In this case, we don't need to move on with the rest of the for loop. We know that the frog has reached the goal distance, and we can just return true. We have another condition that we're going to be checking here, though. So if the frog has reached a negative position, we're defining this as sort of a state that shouldn't exist. We're saying if current position is less than 0, we want to return false. In this case, we don't want the frog to be hopping anymore, and we're just going to return false and say that the frog didn't make it to the goal. So that's it for our for loop. If, however, we already took the maximum number of hops and we didn't reach our goal distance and we didn't reach a negative position, outside of this, we can just return false. The reason why is this is our third case where the frog has taken the maximum number of hops without reaching the goal. Sad. And that's about it for the code for this method. So let's go ahead and use the examples to test it out. All these examples, the goal distance is 24 and the maximum number of hops is 5. So let's keep that in mind as we're going through the examples. So if we look at the very first one, let's set our current position to 0. The frog is at the starting position. We know that we are going to hop 5 times. And then the first value returned from hopDistance is 5. So we go from 0 to 5. 5 is not greater than or equal to 24, so we don't return true. And 5 is also not a negative number, so we don't return false. So we move on to the next hop. The next hop returns 7. So we add 7 to 5, which is 12. We compare 12 to 24. 12 is not greater than or equal to 24, so we don't return true, and it's also not negative, so we don't return false. We'll move on to the next hop. So this is -2. We're actually moving backwards. So now we're at 10. We check this condition. It's not true. We check the negative condition. It's also not true. We move on to the next hop. So this one is 8. So we add 8 to our 10. We're comparing 18 to 24. It's not greater than or equal to, but it's also not negative, so we keep hopping. Move on to the final hop. This one is 6, so that brings us up to 24. In this case, 24 is actually greater than or equal to 24. It's equal, so we will be returning true for this example, which is exactly correct. Moving on to the next example. Now we still have 5 hops that we're given. So we go from 0 to 6. 6 is not greater than or equal to 24, but it's also not negative, so we move on to the next hop, which is 7. So now we're at 13. 13, not at the goal distance and not a negative position. Next hop, 19. 19 is not the goal distance, but also not negative, so we move on to the next hop, which is 6. Now we are at 25. 25 is greater than 24, so we have reached the goal distance. We can return true for this example, which is correct. And notice we don't have to finish out the rest of the for loop because we're returning true early. The next example we're still having those 5 hops. We are going from 0 to 6 in the first hop. 6 is not greater than or equal to 24, but it's also not negative, so we move on to the next hop. We go back 6 distance, so now we're at 0. 0 is not greater than 24, greater than or equal to 24, but it's also not a negative number, so we move on to the next hop. The next hop is 31. We move 31. So 31 is actually greater than or equal to 24, so we have reached the goal distance, and so we return true, which is exactly correct for this example. Moving on to the next example, we're going to be hopping up to 5 times. We go from position 0 to position 4. 4 is not greater than or equal to 24, but it's also not negative, so we move on to the next hop, which brings us to 6. 6 is not greater than or equal to 24, but it's also not negative, so we move on to the next hop. Then we hop -8, which brings us to -2. Unfortunately, when we compare it to Unfortunately, this is a negative position, so we are going to be returning false for this example because this is one of the cases in which the frog has reached a negative position. Final example, we are still going to be hopping up to 5 times. We go from 0 to 5. We compare that to 24. It's not greater than or equal to 24. It's also not in a negative position. We move on to the next hop. We go from 5 to 9. We add 4. 9 is not greater than or equal to 24, but it's also not negative. We move on to the next hop. which brings us to 11. 11 is not greater than or equal to 24, but it's also not a negative position. We move on to the next hop, which brings us to 15. 15 is not greater than or equal to 24, but it's also not in a negative position. So we move on to the final hop, which brings us to 18. Unfortunately, 18 is not reaching the goal distance. It's also not negative, but we're not going to, if we try to increment our I again, we have reached the maximum bound of our for loop, so we're not going to go do the logic inside of the for loop, but it also means that we haven't reached the goal within max number of hops, so we're just going to be returning false for this case, which is also true. If you get rid of the pseudocode, here is what our simulate method looks like, where we have a variable to keep track of the frog's current position. We have a for loop that loops up to max hops number of times. We add hop distance to our current position to keep track of where the frog is. If at some point within the for loop we reach the goal distance, which means that our current position is greater than or equal to the goal distance, we're going to be returning early, returning true. If, however, we are in a negative position, we're going to return false, we're going to return early. If we get through the entire for loop and we didn't return, we know that we already used up all of our hops, and we know that we didn't reach the goal distance, so we have to return false outside of that for loop. Hopefully this helps you out with this simulate method. If you have any questions, feel free to leave them down below and I'll get back to you, and I hope you have a great rest of your day.